Let's continue with our revision for the algebra test. We'll now address questions which deal with powers. Powers and logs are very related, but we'll separate tutorials for powers for questions 13, 14, 29 and 30, and logarithmic questions, but please keep in mind that these questions are related. So what do we need to know about powers? A few things that we will motivate further, but for now we'll just try to remember them. If you've got a to the power of 3 plus multiplied, not plus, multiply by a to the power of 4, this is a to the power of 3 plus 4, and this is a to the power of 7. That's a very important piece of algebra that you need to remember. When you multiply a to different powers, the powers are adding. Now, if you for some reason don't remember that, there's still a way to recover. You can think of some example which is easy to understand. In this case, 2 to the power of 2 times 2 to the power of 3. What does it mean? Well, it means that you have 2 times 2. That's your 2 to the power of 2. That's what it means. Power tells you how many times this needs to be multiplied. Multiply by 2 times 2 times 2. 3 times. If you expand brackets here, which you can easily do, you just remove these brackets, keeping the multiplication there. How many powers we've got now? 5. It's 5 2's, and therefore we have 2 to the power of 5, which is 2 times 3. Now, in another example for handling powers, you might have something like this: 3 a to the power of 3 all to the power of 4. And in this case it's different. It's not adding them. It's multiplying 3 times 4, which is a to the power of 12. Now, once again, you can use 2's to not such a high power to really try to understand what's going on. If you've got this expression, all to the power of 3, what it means is that you have 2 times 2 and you repeat it 3 times. How many altogether after we remove all the brackets? We could count and see that it's 6. So 2 to the power of 6. And how we get this 6? Well, it's 2 times 3. So in this case, we are multiplying them. So don't confuse those two cases. It's very important to recognize that these are two different situations. And we'll now do a few examples which help us to do these powers. Now, we are asked to express each of the following as a single power of 10 for question 13 and 14. And here we're given a root 6th power of 10. What it will be in terms of power of 10. In other words, what is the power here, this x in here? Well, in order to figure out what it is, you need to remember the definition for the 6th root of 10. What is this definition? It's such a number that if you raise it to power 6, it should give you 10, what's inside this power 6, back with the power of 1. We don't write 1, so 10 to the power of 1 is simply 10. Now, how could we achieve that? Well, we'll use the rules that we just revised. What we'll say is we'll replace these by these, putting x in place of the number that we don't know. And we want to keep this equality. Now we expand these, and when we expand that we need to multiply 6 by x. Again 1, 10 to the power of 1, which is equal, simply is equal to 10. Now for these to be equal, these two must be equal. 10 to some power is equal 10 to the power 1. That means that this power, 6x, should be equal to 1, and therefore we get x is equal 1/6. Now for your test now, you just need to remember that these is equal these. And you have some other root. It's quite easy to show that any root of a, any nth root will be equal a, where a is any positive number, to 1 on n, where n is any whole number. So it's an important formula to remember. But here we motivated these. We didn't just simply memorize it, we actually motivated these. Now, what else do you need to remember for question 14? For powers, there's one important thing there. If you have, for example, 1/2, that could also be recorded as 2 to the power of -1. Now, -1 is kind of an obscure power. It's hard to understand how you can raise 2 to a negative power. So where does it come from? Well, it comes from this simple logic. You've got 2 times 1/2. As we do that, we multiply and get 2 divided by 2. And it gives you 1, right? Now, we want to if we want to logically represent 1/2 by a power, how should we proceed? If we put x in here, what this x should be? So that we'll get 1. What's the logical explanation for this? We'll discuss these a bit later, but 1 could be represented as 2 to the power 0. In fact, any a to the power 0 is equal 1, where a is greater than 0. And we'll motivate it later. But if we'll agree with that, then what we have here is 1 plus x is equal 2 to the power 0, and then 1 plus x is equal 0, and therefore x is equal -1. So we're logically coming to conclusion that this number, 1/2, should be represented as 2 to the power of -1. Now, this in itself is not an obvious fact. So how could we possibly argue about that? How do we raise something to power 0 and make sense of it? Well, the rationale is also quite simple. So if we try to find, for example, we have 2 to the power of 2, to be specific, and we multiply it by some number, which is 1. And we want to represent this 1. And we obviously have 4, which is 2 squared, multiplied by 1 is still 4, or 2 to the power of 2. How could we represent this as a power of 2? The only logical way is to put 0, because then we'll have 2 plus 0, and then we have still the rule of adding powers valid. So therefore this gives still the same number. When we multiply by 1, nothing changes. So in other words, taking a number to any power and multiplying it by 2 to the power of 0, we get x plus 0, which is 2 to the power of x. So therefore, these could only be 1. So that's another way of looking at it and justifying this expression that 2 to the power of 0 is equal to 1, and you can equally take any base a and motivate this fact. So what do we learn here? We learn here that when something in denominator is in denominator, it's equivalent to a negative power. How could we apply it to question 14? Well, we have this expression which we need to simplify. And the way to simplify it is, remember, this is 10 to the power of 4, all to the power of 2, which will give us 10 to the power of 8, plus 7, because we're multiplying these out, we're adding powers of this and this, and we're dividing by 10 to the power of 8, and because this 8 is in denominator, essentially what we need to do is take this 15 and minus 8, and we'll get 10 to the power of 7 here. So that simple algebra of powers. Also, this one could have been done like that, maybe a little bit quicker. When you have 10 to the power 8 here, in numerator and denominator, you divide by it and you simply get 10 to the power of 7. So sometimes you can come a bit faster, but this is another motivation for understanding how this power in denominator actually becomes this to the negative power. Other examples that include power is in question 29. So one has to solve an equation which involves powers. You're asked to find x for this simple equation. A lot of mathematics is actually based on formulating equations from real-world problems and then solving these equations. So very often we just solve equation, but these equations actually do come from the real world. We'll see in the lectures how these equations could come around when we're trying to solve for radioactivity, for example. Now the question is, what is x? How could we proceed? In this case, the logic is pretty simple. All you need to do is represent this number as a power of 4, which you shouldn't struggle with. 16 is equal 4 squared. And because this has to be equal, this and this have to be equal. And the answer, therefore, to the question 29 is x equal 2. Now that could be handled pretty simply because you have a simple number here. But think what to do if this number is replaced by 10, for example, which is not a simple power of 4. How do we proceed here? We proceed using logs, which will be the next tutorial. So we'll go to logs in the next little video. But before we do so, we'll just finish with question 30, which involves powers, and hopefully you can do it before I finish, because we just revise these rules. When we have a multiplication of 2 to this power and 2 to this power, all we're doing is slightly more complex expressions, but we just add these fractions. If we modify this question a little bit, I'll just put this all to the power of 6, then it will be 2 to the power of 5p times 6. 5 times 6, 30. So So we'll have something like that. So equally likely question for question 30 in the algebra quiz. So again, these questions involves powers, and if you need more examples, more motivation, definitely go to this free resource, Khan Academy on the internet, and investigate how you can even go through some tests for yourself. It's quite important for you to get the powers right. And in the next one, we'll go on to the logarithms.